Welcome to the final of the keynote addresses we have for this conference. This is going to be Telco Futurism, so I think we're looking to the future. Why intersections, Telco Futurism, why intersections with other technologies and social trends will drive the communications industry. Dean Bubley from Disruptive Analysis is going to talk to us and bring us out. After this, we have box lunches available in the expo, so everybody should come and spend that last hour. And then following the box lunches, I always just bring people over that are still here, and you can have a look at the real-time communications lab, which is in the research tower a few blocks south of here. Or we can just continue the discussion over lunch, but sometimes it's fun just to go down there and see where the development and the research work is being done. It won't be where the ICE is taking place. That takes place at the Wheaton campus, the NINA ICE testing, but you'll see the rest of the lab activity there. So sort of after box lunches gets distributed, I'll wave and shout if you want to take the walk down. Okay. And so here's Dean. Thank you.
Thanks, Carol. Hopefully my voice lasts for the next hour or not, but if I start sort of squeaking and croaking, then I'll have to try using a side language or just pointing at the slides. So this is the last session, so I get to be a little bit irreverent. It's a small audience, so feel free to interrupt or throw things if they're not too hard. I'm going to try and be a little bit controversial about a few things. One of the reasons I called my company Disruptive Analysis is I like being opinionated about things, and so there's going to be a few kicks at received wisdom. There's going to be some discussion about the politics of the telecom industry. Heard a little bit about that from Svein the other day, but I'm going to be perhaps taking shots at a few sacred cows. And I'm probably going to be going all over the place in terms of coverage, because I cover, I'm an analyst and consultant and futurist, and I cover a lot of different things. The reason that I've come to this event in the past is because of my focus on voice and video and WebRTC, real-time communications. I was the first analyst to put out forecasts on WebRTC about 4 or 5 years ago. But that's only part of what I do, and I actually spend quite a lot of time looking at the future of networks, whether that's 5G, low power IoT networks, virtualization, NFV, that side of things, spectrum policy, and so on. But then also within communications, I look at enterprise communications, consumer messaging, and voice and social applications, and where we sort of take this idea of voice and context in the future. And what I've started doing more of in the last year or so is what I call Telco Futurism. Now, this is partly just because it gets me opportunity to go to lots of cool events and meet people doing cool stuff with drones and artificial intelligence and Bitcoin and blockchain and all the other sort of sexy technologies that are occurring. But also because I think this is an absolutely fundamental part of the communications industry going forward. There's a lot of technologies which are not telecoms or communications technologies, which are going to have an impact on service providers, vendors, and in some extent academia as well. And I think it's something that a lot of the companies I speak to and also regulators and industry bodies don't quite get the importance of some of these other adjacent or either adjacent or orthogonal trends. And I'll talk through that a little bit in a few minutes. But I want to sort of step back a bit and sort of reassess where we are as an industry or as a beyond industry into academia, looking at conventional notions of telecoms. And certainly the past has focused on calls, minutes, and connections, and so on. I've sort of often said that the minute has been a 100-year old idea, which was made an awful lot of sense as a way of measuring a quantum of communications in the past, when you had people physically switching connections, but has got progressively less useful over the decades. I mean, no one has ever said, "Oh God, I wish that conference call was longer. It would have been more valuable to me." So, there's not a correlation between. I haven't got this chart on here. I did an analysis of. I looked at Rotten Tomatoes, the movie rating website, and essentially looked at the difference between really good movies and really bad movies, and they're the same length. There is no correlation between value and time. So, as an example, I mean, this is from a couple of years ago. I don't know who's come across this app before, Be My Eyes. It's a really, really great example of communications which is not a call. It's a smartphone app designed for blind people to work with a crowdsourced set of thousands of people around the world to help them solve problems. So if I was blind, I could use the app on my phone to maybe say how many people are in this room. The video would go out to the internet to a volunteer, and audio would come back the other way to me. And that would be an assistive app for accessibility in that case. And there's certainly not a phone call, but it is undeniably communications in real time. And it's that type of imagination-driven, problem-solving approach that I think that the communications industry needs to adopt. There's much more design rather than engineering in a lot of ways. And this sort of, I'm going to make given we're in the middle of one of the most unprecedented years of politics, I'm going to make a couple of political comments. And certainly that app came from a Danish inventor's idea. And you probably don't recognise the green and red flag, I imagine. It's Belarus. And I'm using Denmark and Belarus to sort of, apologies if anyone here is from a Belarusian background, but to give examples of openness and closed societies, around entrepreneurialism and liberalism and experimentation and freedom on one side, and sort of over-tight control and authoritarianism and perhaps process-driven governance on the other. And you're probably not going to be surprised to hear that I'm going to draw the analogy with the communications industry as well. And that line came from a really good book by a guy called Alec Ross. 21st century is a terrible time to be a control freak. And yet, in my journeys through the telecoms industry, I meet quite a few people who would fit that description. Now, clearly in some areas, for example, public safety, there's a certain tolerance of control freakery which is entirely understandable and even desirable. But in more general sense, in terms of communications that we all use, I think that is looking backwards. So, what's going on across the industry? And I've tried to sort of drill down into what I'm seeing in telecoms overall, and all of these overlap, but undeniably an accelerating shift to IP, whether it's fixed, mobile, core and transport networks. This is fairly uncontroversial. Equally uncontroversial, faster networks, and especially where they're used for internet access or mobile access. Not exclusively, but certainly the scale of the cellular industry is very much driven by 4G and now 5G being used for connectivity, and the bulk of 4G data use is to and from the public internet. There's an open question about 5G, whether that will be the same. We'll see. The software telco and the cloud, countless things about NFV and SDN, and that's progressing over time, perhaps not as fast as many thought. There's an interesting dichotomy here. I think 5G, in some ways, is evolving faster than people think, and NFV and SDN is evolving more slowly because of a variety of reasons. That has all sorts of interesting implications because the original assumption a year ago was that 5G networks would be all virtual. Everything behind them would be virtualized. It would be cloud everything. But what's happening now is that the radio guys seem to be getting their acts together faster than the core network guys. And there's now calls for the radio part to sort of steam on ahead as fast as possible and let the virtualization catch up with it when it can. And that's got implications downstream in terms of the services and infrastructure and investment and in some ways regulation that relates to it as well. Commoditization. I'm not going to bang on about OTT services and all the rest of it. I've publicly called for people using the word OTT to be fired for incompetence, because essentially OTT means bits of the internet we don't like, which seems a fairly disingenuous term in my view, given that every telecoms company I've met has its own website, which seems to work perfectly well over the top of its customers' access. As well as using things like voice over Wi-Fi, which are also over the top by definition. So there is this drive in the telecoms industry for new services and new sources of revenue. We heard the Telenor presentation from Svein the other day, and it's certainly cropped up in a couple of other sessions. And I think that's all very well, but there's more to it than that. And I'll come on to why I think these, it's a bit of a clunky phrase, I need to probably work on it, but orthogonal futures. There's probably a Twitter handle that I could register for that, but I haven't yet. So there's a lot going on, and to be fair to the telecoms industry, I know I give it a big kicking from now and again. There's an awful lot on people's minds. If I was a CTO at the moment of a large operator, there's a ton of stuff that's on my plate. Some of this is standardized, some of this is a technology complexity, some of it is here and now. All of it is happening at the same time with unknown interdependencies, whether it's low-power networks for IoT, whether it's what we do about our old PSTN, say 5G, next generation of fiber connectivity, you name it. And they're all linked in some complicated set of ways. Sometimes they're linked deliberetely because standards are conditional upon each other. I think that's a mistake because it tends to make everything more brittle, and it means that you get you get dependencies. That technology A and service A can't be launched until technology B gets its act together. And this, to my mind, is a problem, because it means that there are lots of scope for disruptions coming in from outside, which can derail various of the sort of projected visions and roadmaps from the purveyors of any of this. So, I worry quite often that the telecom establishment, and we know who they are. I mean, I've used 5G PPP. I could have put 3G PPP there, and there's other bodies as well. I've accused various of these bodies of strategic overreach for years, where they see a good idea and then immediately jump a million miles to, this is how traditional telecoms companies can take over the internet, run the world, monetize everything, this is our utopia. And then use that as the basis, that frankly sci-fi vision, as the basis for standards and development of internal collaboration amongst parties. And I think that it's good to be ambitious, but I think increasingly becoming over-ambitious is dangerous, because you end up with other people eating your lunch while you're still reading the menu. So, I'd make an argument that, and to be fair, a number of these bodies are getting better. I was at NGMN's 5G conference last week, and to be fair, they had representatives of the automotive industry along to talk about what BMW's vision for 5G was. So there are some signs that there's movement, but I do worry that some of these bodies are a little bit Machiavellian at times, or just slow. And let's face it, this year has proven us one thing, that being anti-establishment, and I'm not going to make any judgments here, the internet and the public and social engagement, as well as businesses, make anti-establishment politicians, more viable, even if they don't always win. But there's certainly, there's probably a couple of the logos there that people aren't aware of. The two logos are the hexagon is the transhumanists, and the other one is the Pirate Party logo. And there's a few others. So, for example, the fellow in the bottom right-hand corner there is Duterte, who's the Philippines president, who, let's just say, is not the most diplomatic person on the world scene at the moment. So, moving back to communications, tools of disruption are becoming mainstream. I put the FCC in there as a potential tool of disruption, as well as open source technologies, things like the Raspberry Pi we heard talked about earlier on. LinkedIn, I've got there as a disruptor. LinkedIn is disruptive because it means that lots of companies that are not in the telecoms industry can hire communication specialists more easily. So all of the car manufacturers, all of the energy companies, all of the transport companies, they are under no illusions that mobile and wireless and communications is important. So they're going and hiring people who can do stuff themselves. They don't want to rely on the traditional telecoms companies. There's this attitude of telecoms is too important to leave to the telcos. We want our own spectrum. We want our own networks. We want to create customized versions of things. And that runs opposite to the received wisdom of standardizing everything. Because the more open source there is, the more it is possible to create customized layers or customized, optimized versions of particular, whether it's communications protocols or anything else, because the baseline is there already. And so if you can hire the people, you've got some baseline technology available essentially freely, you can then start to think, well, actually the economics are looking a little different now to create proprietary versions of stuff. And I know the word proprietary always worries people of, oh my God, we're sort of going to head into this world of fragmentation. But there's some important reasons why fragmentation is sometimes valuable. So because I've been looking into it, I'm going to take wireless as an example, and 5G. The idea is that 5G, a bit like 4G, is going to be one network to rule them all. It's going to embrace everything. There's going to be one set of standards. We're going to have these wonderful ideas of network slices controlled by carriers to deal with, low power I/O, Internet of Things, ultra-fast mobile broadband for the iPhone 12 or whatever it is, and also sort of critical communications, everything else. But lots of these groups have their own quite specific needs. I spoke recently to someone from the utility industry in Europe who was saying, never mind sort of smart homes and smart meters, what we're worried about is managing the high voltage grid. And we want to be able to manage that better, especially if we're going to be using more distributed sources of power and various other issues around security and resiliency. But we can't manage our high voltage network based on the cellular industry's connectivity. And this was at a regulated event, and all the cellular operators, well, why not? I mean, 4G is fast and reliable, 5G is going to be even better. And the electricity guy said, because your cell towers run on our electricity. And so unless you're going to put diesel backup on every single cell site, if your grid goes down, or if our grid goes down, so does yours, and so we can't fix ours. Therefore, we want to have our own radio network, which I thought was a fairly compelling answer. They also said that their idea of QoS is having helicopters on standby so they can go and fix things within minutes, which I thought was a slight phase shift from what we normally think of in our industry. There was a similar issue that was raised by a guy from the oil industry who said that we want to use ideally cellular or similar connectivity on some of our oil platforms and everything else, but we want to have the ability to switch it off. Why do you want that? Because we have explosives. And we can't have, we want to be in control of the RF environment. So each of these industries and groups have their own sort of niche requirements. And increasingly, I think they're going to want to do their own thing. One of the other trends I see is what I refer to as arbitrage everywhere. It is possible to find multiple ways of connecting or creating any application or service or functional feature. So we already see this in mobile and fixed networks. There are multiple ways of connecting our remote sites. There are companies that are allowing for arbitrage between different providers and platforms and connections. So this, I don't know if anyone here is familiar with this term SD-WAN, software-defined WAN. That is a way of using essentially a box which aggregates multiple ordinary plain vanilla internet connections for a cheaper replacement than a fixed MPLS virtual private network. And there can be as much as a 30 or 40 delta in price between a managed network and an unmanaged one. And what you can do is say, well, if there's that big a difference, get 3 internet connections. Bundle them all together, put a box in the front, throw the packets down all of them, and take whatever comes out first at the other end. And so you have this sort of a quasi-QoS approach, using sort of redundancy rather than one managed connection. And this is occurring in all sorts of other things. We all are used to using Wi-Fi, tactically alongside our cellular connections. And the same thing is going to happen in terms of communications. We now interchangeably use voice, messaging, video. We'll tailor our use of communications to the particular use case, our own preferences, but also to what works on any given day or week. And if I'm somewhere where I know that roaming phone calls are expensive but SMS is cheap, I'll change my behavior, because I'm happy to sort of view them as essentially equivalent in terms of my outcome of getting a taxi or whatever I'm actually trying to do. So one of the things that, and this is where I'm going to annoy a couple of people, I think that we hear a lot about dumb pipes in the industry. I think we should be just as worried about dumb services that just do one standardized thing, of whether it's phone calls or, Nokia, RCS. I've been a long-term critic of RCS's film of messaging. I've called it a zombie. I've been following it for 8 years. It's still dead and shambling around trying to eat your brain. And I'll leave it at that before I have people throwing things at me. In fact, the 28 days later was a reference. I did a blog post about a year ago. I realised it had been 7 years since I first heard of RCS, and so it was 28 quarters later, and still nothing had happened. But anyway, moving on. So the industry is looking for new sources of services, and of course there is a theme that if you go to any, actually it's not been bad at this event. I haven't heard this word used much at all, but there is a theme that you often hear at any industry event around communications these days, which apparently is the thing which will save all of us. What do all these technologies have in common? Well, they're all digital. Now, whenever you hear anyone say, digital technology will save the industry, digital services, you might want to point out to them that Morse code was digital. In fact, an abacus is digital. Digital is not necessarily something that means that it's a successful modern service. All computing has been digital since the 1940s, pretty much. And yet, you have this term that is used by policymakers, by CEOs, by regulators. There's this digital single market initiative in Europe. And essentially it is a polite way of saying technology, most of it from the internet, but we don't want to admit it. Plus, by the way, we're from the marketing and PR industries and politics when we don't really understand technology and computing and telecoms anyway. So, as well as OTT, I have digital on my list of, can I say trigger words, for terms that I tend not to use in my presentations. So what else is happening? Where's the fun stuff going on? And this is, to my view, the nub of this. The future is getting closer faster than it used to. I mean, okay, this is a bit of an unfair example, but we discovered gravitational waves this year, 100 years after they were predicted by Einstein. And so that was obviously quite a long time between expectation and reality. But perhaps more recently, we've had autonomous vehicles, and the first sort of big move to this was around 2004. DARPA did a challenge for who could drive the furthest over a desert course. I think the answer was about sort of 5 miles out of 100 miles before the last one ended up in a ditch. Whereas now we routinely have prototypes of self-driving vehicles of all sorts whizzing around, and actually it's becoming more of a regular problem around regulation and the insurance model and liability model, whereas the underlying technology is getting pretty good. So we've got maybe a dozen years between concept and becoming mainstream, depending how you define mainstream. Bitcoin, that was released in 2009. Probably could be described as being mainstream in 2014, 5 years. Drones, first commercial sort of quadcopter, 2010. That's 4 years from, almost from prototype to mainstream to Christmas present. And that's clearly taking on a life of its own now. And this isn't just in the, if you like, the communications and IT space. You have things like CRISPR, which is a genetic technology used for gene editing that was essentially gone from invention to commercialization amazingly quickly and spawned dozens of similar innovations in its wake. So all of these are happening a lot faster than they used to. It used to be that futurists, if you met someone with the job title of futurist or envisioning, chief envisioning officer or something like that in a telco, he was typically a guy, sometimes a woman, but usually a guy in a lab with brain the size of a planet, medium-grade communication skills themselves, and they were usually wheeled out once a year for CNN or BBC to talk about the home of the future or something like that, before the service provider sort of put the way safely tucked away in the lab for another year, and not actually allowed to touch anything real or create anything that's going to be driving value. And so they had these people who were like talking about 10, 20 years' time, we'll all have these amazing technologies. What's happened now is that 10 to 20 years has shrunk to 3 to 5 years, and it's being renamed as foresight quite often, which is not a bad term. And there is at least a bit more of a view to how commercialization might happen, and some work with companies that are actually doing stuff in the field. My concern, though, is that horizon is narrowing even further to 1 to 2 to 3 years. And that's important because that is the same timelines on which most of the things we're inventing today are expected to be commercialized. So in other words, there is the cadence of innovation and technology is such that things are starting to risk becoming obsolete before they're even launched. And that is a real concern. Because there's an awful lot of things. I mean, this software-defined WAN has come at a really bad time for the virtualization and NFV sector. There were all these visions about 2 years ago about service providers offering enterprises what's called network as a service, where you'll get a managed network with all these great functions in the cloud. We're able to do prioritization on your internet traffic. We'll be able to sort of have firewall as a hosted service, and 100 other things as whizzing as virtual machines linked to access to add value to the carrier access. But what's happened now is that's been blindsided by this technology, which basically says, you know what, you don't need to have fancy access with all these virtual functions in one operator. You can have 3 operators or carriers coming into your building, and will do the fancy stuff either in a white box server on your premise or perhaps on a cloud platform somewhere else. And so it's sort of end run the sort of more grandiose visions. And this is a particular risk where you have complicated architectures and multi-year programs that don't have modularity and ability to get sort of quick wins out sooner. So I contributed a chapter to a book earlier this year. It's called Future of Business, written by or edited by Rohit Talwar, who's a futurist. I know Rohit quite well, and he got a whole group of people to write a book. And in fact, this was a time that the book was created, I think, in less than 4 months from concept to publication, which itself is maybe a third or less of the time of most book publication cycles. So I wrote a chapter on the future of the phone call, and I was talking about WebRTC and contextual communications and video and other things. But what really surprised me was the number of other things in that book that were not just fascinating, but relevant to what I was doing. So there's stuff around AI, machine learning, analytics, big data, blockchain, one of the things I was talking about yesterday, and I've got a couple of slides coming up, and then a whole bunch of other things. Now, some of these were technologies, some of these were social issues, say things like urbanization and the move of populations around the world into cities from rural areas. Some were around the future of politics or finance, and some of them, I'll be honest with you, have absolutely nothing to do with communications at all. It's an interesting chapter on creating artificial meat, but I don't think I'm going to be presenting it on a slide with a crossover with telecoms anytime soon. But if anyone's got an artificial beef burger later on, or cloned steak, let me know. So, well, thinking about this more, what I realise is that increasingly opportunity and value arises at the intersections, either with networks or communication services in particular. And at each of these intersection points, apart from the meat, there is the possibility for value and differentiation. And so if you think back to what I was saying before, that the telecoms industry has a threat that it's becoming core services are commoditized and is sort of running around trying to look for these mythical digital services that it can compete against Facebook or Google. It's missing a trick here, because what is also happening is a huge fragmentation of possible intersections. And these are combinatorial. So you may well find that you have IoT plus machine learning plus blockchain plus networking or voice and video. And if you actually sort of think through the number of permutations, there is no possibility that any one company, even Google, or even using sort of a platform-based approach, can do all of them. So in theory, at least, there ought to be opportunities. But there are also risks that come from this, and I'll talk through that in a minute. And part of the issue I find is that a lot of the people I speak to in service providers don't really understand this vision of the future. They're so locked into the all of this, the list of things I gave before that are quite understandably high on their agenda, that they're not getting a bigger picture of what does a future construction industry look like, where you've got 3D printed parts, where you've got weekly conferences between the architect and the local planners and the construction engineers and so on. And actually the point here being, can we create better buildings faster and cheaper? And communications is an embedded part of the various processes that go into this. I'm not a construction expert, I'm using this as an example. Could equally be in finance or healthcare or agriculture or whatever. But rather than thinking of communications as a service, or even as a sort of communications as a platform, it's actually understanding what else is going on and not tying into any one sort of channel of development, because there's so many moving parts that it's very, very hard, unless you have a long-term contract with the government, to be absolutely sure that you've managed the risk. And so I think there's going to need to be a more of a sort of venture capital approach to service development and partnership, where you take lots of bets and hope that one or two of them become winners and big. And not only that, you then expect that even the winners will have a shorter shelf life than you might have wished. The other thing I noticed is that most futurists don't really understand the communications industry either. I keep hearing these sort of words of wisdom. The one that really struck me was this one here, which perhaps wasn't the world's greatest futurist. Wireless power will be beamed to your devices from the same grid as cell towers. Now, I personally don't want to live in a world where I'm getting microwave radiation sufficient to power all of my electrical devices beamed through my head at the phone in the front row. Leave aside the fact that it's fairly doubtful it would go through things like brickwork. But I thought that was an example of the sort of vision, or something, or basically cluelessness masquerading as vision. Similarly, everything will be mobile. No, it won't. Clearly you're going to need fibre to the cell sites. You can do some of it with microwave backhaul, but a lot of connectivity is not going to be cellular, wireless, whatever. There are reasons. There are not many wireless servers, for example. Or wirelessly connected data centers. And I think that some of the commentary that I get from if you like, what I call mainstream futurists is startlingly naive. So I think there is a need to understand that the particular niceties of telecoms, where you've got big, scary IT systems and billing systems, where you've got regulation, where you've got internal organisation and politics and so forth. And then marrying that together with all of this long list of cool technologies and trends. So, going back to this that I open with, Be My Eyes, in a way, is a combination of the rise of smartphones and the cheapness of camera technology. It's the adoption of developer platforms around WebRTC, and also this social trend towards crowdsourcing. So it's not just technology, it's the sort of phenomenon of multiple people and the power of crowds, which is enabled again by things like social media, but is more of a separate issue that we wouldn't normally consider as a driving force between innovation and communications. Real-time communications. There's a whole host of ways in which voice video messaging is going to get cooler. We heard yesterday, 2 days ago, from Anne Lee from Nokia about what happens when you blend a 360-degree camera with augmented reality and conferencing. Maybe I want to contract out manufacturing of a device to a factory in China, so maybe I can walk around the factory with the CEO virtually. I'm wearing the headset and I'm here, and I'm given a proper tour rather than just a PowerPoint presentation. Yeah, I can see that happening. We talked yesterday at a panel about intersection of IoT and communications. And there's a ton of use cases we discussed yesterday. It could be an IoT event that triggers a human-to-human conversation. Maybe a temperature sensor in a machine goes beyond a threshold and it sets up an immediate call between the supervisor and an engineer and the manufacturing, the plant specialist. You could have things which improve communications. Imagine your watch or your Fitbit or phone interacting with the cloud and saying, for an inbound call, the person you're calling is at the airport and running. We suggest that, and it knows it's a sales call, we suggest you might have a better opportunity calling in 3 hours' time. Would you like to leave a message? Or, there's a lot of ways we can use technology around wearables, around sensors, around machine learning and intelligence to make even a basic phone call better. And I think that's an area where there's an awful lot of mashups that we're going to see. We've already got people using the microphones on smartphones as essentially stethoscopes, or ways of tracking people's breathing patterns. You're seeing the camera on phones used to help diagnose eye disorders remotely. And there's such a lot of ways in which, if you think of, what have we got on a device, whether it's a PC or a phone, a microphone, a camera, and then say, well, what happens if we think about that in conjunction with this other cool technology we're seeing? So another one, analytics and voice search and emotional analysis. I went to a demo. There's a company in Chicago called Media Science. Now, this isn't about communications at the moment, but what they do is they sit people down in front of screens with eye trackers. You can measure the heart rate with a sensor, and it also measures the micro-expressions in your face. And they show you adverts or clips of movies or TV shows to gauge your emotional response, which part of the screen you're looking at, and all sorts of other sort of biometric data of indicating whether you believe something, whether you express liking or disgust or curiosity. And I was like, well, we could mash this up with communications apps as well. I've certainly seen prototypes of video conference centers, video contact centers, that allow you to try and determine whether the customer is annoyed or happy. And we certainly use voice analytics and emotional analysis to sort of try to gauge stress within calls as well. And so I think that IoT in particular, and this is this sort of grid metaphor I'm using for my analysis quite a bit, of thinking, what are the horizontal capabilities we have, and how do they intersect with vertically subsectors of whatever trend I'm talking about? So here, IoT, across the top, there's lots of different things, whether that's vehicles, drones, sensors, smart cities, agricultural technology, and so on. And they can then potentially intersect with ordinary voice calls, AR and VR, cognitive communications, video, and so on. And at each of these intersection points, there's interesting stuff to think about. And in some cases, it'll be, if you like, what I haven't had a chance to do is overlay a heat map on top of this of what's really cool and what's a bit tangential. But you can imagine that sort of at each of these points, there is an opportunity for a service or a product, and I think that we underestimate the number of dimensions for innovation that we got in the industry. And in fact, what I increasingly find is when I look at this, that actually it's almost fractal, and that when you drill into any of these points, there's a lot more hidden detail than if you like next layer down if you double click. And so you might have smart city and video. Well, smart city could comprise anything from public transit to waste collection to sensors for public safety to managing lighting to reporting faults in the road, holes in the road. And then you can sort of subdivide that into, send a video message of a hole in the road to the works department because that's non-urgent, or it could be an urgent conference call or urgent video call for public safety reason if you're working through an area of the city where the lighting has failed or something like that. And so there's more and more fine-grained intersections underneath this. So I'm not yet really willing to describe myself an expert on AI and machine learning, but I'm already seeing a proliferation of ways in which, whether you call it cognitive or intelligent computing, is transforming communications, both from the network side, the commercial side, and also we saw yesterday a demo from IBM about things like contact centers and virtual agents. And so it could be sort of real sort of hardcore network engineering around optimizing of paths of network pathways. It could be looking at the billing system to try to predict who is most likely to jump to another service provider. Fraud detection is a classic one. I had another presentation the other day about managing Wi-Fi networks and using machine learning to spot things that cause problems and learn from them, so that next time if someone's got a 5-year-old BlackBerry with a particular operating system and the experience was that it caused interference on Wi-Fi, you know that that's a potential risk. So maybe if you've got a managed Wi-Fi service, you try and put that on a dedicated access point, or you block it from having access, or whatever you do. But you try to learn from experience and automate that. For each of these technology areas, it's worth noting that there is risk and opportunity. So I went to an event on quantum computing and other quantum technologies a few weeks ago in Cambridge in the UK. And it was striking that there was, on one side, there was some really interesting stuff around allowing you to create hyper-secure networks using what's called quantum key distribution, and making sure that networks are mathematically provable, impossible to tap or to listen into. But on the other hand, there was another presentation which said a bunch of the encryption algorithms you've been using for years are going to be dead as soon as we get decent functioning quantum computers, maybe on a 5 to 10 year view, particularly any algorithms that rely on things like factoring large numbers, for example. Now, there's a bit of a debate as to how fast quantum cryptanalysis is going to emerge, and whether you can do it on a general purpose, whether you need a general purpose quantum computing platform or various sort of dedicated things to particular problems like optimization. But the fact is that there's a light side and a dark side here, and I think that we need to be aware that for all of these, there are risks and opportunities for substitution, or for working around things that we think are either ours in perpetuity, or they're existing plans we have that might get derailed by these trends from adjacency. The other directional aspect here is the use both of these technologies both to create new services, but there's also ones which allow better operational management as well. So I'm taking drones as an example here, where there's certainly an interest in providing 4G and 5G connections to drone operators, to maybe using drone streaming video for anything from sports coverage to looking at fields for agriculture and entertainment. This is a sort of a technology area that potentially allows communications operators and their suppliers to offer dedicated services to vertical industries, and that's quite an exciting opportunity. Public safety, for example, I saw a vendor recently talking about using drones to fly ahead of an emergency vehicle to offer either sort of a picture of the traffic, but also it could be a building, or getting operational intelligence on a particular police or fire situation. The other side of this is the internal use cases of drones potentially in the telecoms industry. In fact, the first one was I saw was last week. Verizon used drones to check out its network in Florida after the hurricane. and they were looking to see, they couldn't get vehicles down the roads because of flooding, but they could use drones to check out the state of the infrastructure and whether it needed repairs and some maintenance and so on. You're also seeing drones being used for testing and mapping of cellular network coverage. It's a lot easier than driving a van down all the roads. You can just position it at different altitudes, which obviously a drive test can't do. There are a whole bunch of things that are interesting around delivery. Now, on one side, it might be Amazon delivering you a parcel, but equally well, it could be AT&T delivering new phone or whatever to a remote location. I don't think that's going to happen anytime soon, but it's interesting. Or you could imagine improving maintenance operations by getting spare parts out to an engineer faster without needing a return to base. Blockchain. Been mentioned a couple of times. I did a session the other day. Probably don't have time to go through all of this now. Blockchain essentially is a form of distributed database. Originally came from Bitcoin as the distributed ledger, which proves that you have the money you're supposed to and you can't spend it twice. It's quite cleverly constructed so that the process of validating transactions and encrypting them itself earns more coins, bitcoins. That's relevant only to the sort of Bitcoin example, and it has its problems because it requires huge amounts of energy to do that. Uses concept of proof of work to sort of do a mutual validation of this sort of distributed database between multiple computing nodes, and it combines blocks of transactions or data into groups of transactions into blocks, hence the term blockchain. That's a terrible explanation, but there's an awful lot of stuff, and I was skeptical, but I'm starting to understand why it's interesting and important, because it changes the nature of proof and trust, initially for financial transactions, but potentially for anything that requires an intermediary or anything which requires groups of disparate organizations to share data, either to share write or read access to data. So you can imagine a number-portability database or what's called data integrity applications, where you can prove that data is the same that it was yesterday or at some earlier point. There are, as I say, this isn't a panacea. There is an awful lot of sci-fi visionaries in blockchain as elsewhere who will tell you that actually this is the most important invention since the internet. It's going to redefine society. It's going to redefine what we have think of as a company, and quite frankly, the world essentially only started in 2013, and the future is going to look immeasurably different. That's possible, but I think we'll probably have a few years warning of revolutionary changes in human society. In the meantime, this is potentially a good tool for the telecoms industry in all sorts of ways, and it's one of these grids again, whether it's around micropayments, identity management, what are called smart contracts, where you can have a computerized contract where you have the outcome is conditional upon particular inputs. So you could have an output which is, I'll use a non-telecom example. Imagine you're shipping shipping goods in a container, but it's perishable, they're flowers or food, and you want to say, I will only pay you for the shipping if you can prove that the container was at less than 0 degrees centigrade the whole time. And so you can basically key the contract to the temperature sensor, and it will trigger a payout automatically if the conditions are met. So that would be called a smart contract. And the same thing is potentially interesting in all areas of communications industry. And again, you have multiple verticals of communications, whether that's running the network itself, whether it's roaming and wholesale, real-time communications, or, for example, one use case I heard at an event recently from a large US carrier is they were looking at using blockchain to store data relating to call records. So that if there's a lawful request to hand over data, there's a way to prove chain of custody of the call detail records that came out of the network, and then at a later date were requested by law enforcement, and saying, well, how can we prove that the data set we're handing over is the same which came out of the network originally? And the idea is that if you're able to use a blockchain-based proof, you have encoded that data immutably, so unchangeably, and then you can prove it is what it was. So there's all sorts of ways that this, again, intersects. Now, I've started looking into blockchain recently. I think that the telecoms industry is interested but slower by far than, say, the finance industry. But it's one to look out for because it's moving so fast, it's astonishing. I noticed that just this morning, one of the big banking blockchain consortiums that was coming out with an enterprise-grade blockchain solution open-sourced their platform, which a bit, to me, is a admission that whilst they might be able to do it in banking, they're not the ones who are going to take that into other industries, and that's what they would like to have as a it's called R3 Corda, I think. Skip that. One of the things that's hard to realise in communications is there's a bunch of stuff which is going on outside of our normal view of the world. This isn't really futurism. This is more talking about orthogonal trends. So quite often people will say, "Oh, Wi-Fi is going to be a seamless part of 5G networks, and it will, you'll roam from one to the other. You won't have to think about connecting to Wi-Fi. It'll all be looked after for you." Well, that's all very well, but it rather ignores who else the other stakeholders are for Wi-Fi. So this is a bus I saw in London recently, which offers free Wi-Fi sponsored by Magnum Ice Cream. Now, I'm fairly sure that when the standards for Wi-Fi authentication were being developed, they didn't invite Unilever or whoever it is who makes Magnums to the table. But what we have here is Wi-Fi being used as a market source of marketing value, and there's a bunch of other new entities in this value chain, besides presumably the cellular operator that's linking to the bus. You've got the bus owner, you've got the marketing agency, you've got whoever does the implementations of Wi-Fi in vehicles, you've got presumably someone's doing a website for the ice cream company so they can capture your details and give you a coupon for a free ice cream or something. And all of this is going out completely separately from what the telecoms industry thinks it's doing with integrating Wi-Fi into cellular infrastructure. This is someone monetizing the seam. This isn't seamless. This is someone who's seen the seam of connecting to Wi-Fi as being a source of value. And I think that spotting these things is really hard, but they're occurring all around us. And so whenever we think that there's a nice clear line between what we're inventing and commercialization, you need to think there's someone else who's coming in orthogonally from the side who might try and derail that. And this is linked to another issue. There's many ways to solve any problem. With technology becoming ever cheaper, ever more open, ever more flexible, developer platforms as a service. Imagine you want to create a vehicle without a driver. Let's say you've decided that for construction vehicles on site, you'd rather not have to get someone out to a quarry 300 miles away. So then the question is, do you create a completely autonomous vehicle, or do you have it driven remotely with someone wearing an AR headset? And the two are very different technological approaches, but they have the same net result of not needing a driver in an expensive location. And they have differing requirements on the network, different requirements on local compute capability, perhaps different intersections with regulation. And for any problem that we can imagine, there's 2, 3, 5, n ways of solving it. So we really can't get too precious about any one technology or platform, because there might be someone else that's got a completely different set of innovations that ends up with the same result, even though we didn't see them as a competitor a year ago. And so, this really comes to the core of the issue for the communications industry is, how do you get from this really quite impressive world of demos and proofs of concept and hacks, which are absolutely essential, but how do you get things into production before someone else eats your lunch? And there's no fixed rule here, because it's clearly something that's going to have to be done on a case-by-case basis. It depends on the service provider or vendor's attitude to risk. I see nodding from Spain here. It's sort of, do you put people in a functionally separate business unit? Do you institutionalize the idea that you ask for forgiveness rather than for permission, even if you occasionally don't call the regulator first to do something? Do you have everything that has to go through a 3-month cycle with your lawyers? Do you have an office full of people whose job is to look at every new thing for cannibalization risk? Or do you accept that someone else is going to cannibalize it first if you don't, and just go and do it anyway? Yeah, and to be fair, some things can't be adopted immediately for all sorts of reasons, particularly integration with legacy systems, if they're safety critical, all sorts of things like that. So, I think that one of the skills that the telecoms industry is going to have to find is where are the niches where we can experiment fast? What can we get up and running today, even though there's other use cases with how can we learn from it? How can we grow our experience from reality, not just in the lab, but from practical experience? So I think that what Verizon did last week was absolutely fascinating, because if you'd asked me how long is it going to take for a telecom company to use drones operationally as part of their day-to-day management of a network, if you said that in 2013, I stood here in 2013 and said, we're going to be using drones for checking out cell sites in 3 years' time, you would all have laughed. And yet we're actually doing this. And I know there's at least one company now, I think Nokia, I saw a press release, I think from one of the Middle Eastern operators using drones to connect to check cell site coverage, for example. And I think that's great, because those are uses which are not displacing anything that's existing. They don't need heavy-duty integration. There's an obvious business value. And they also generate experience and, then potentially lead to future revenue generation as well. And they're very much out of the lab, much as the lab, thanks to our hosts, has a relevant role to play. But we need to also get into commercialization, or at least if not revenue generation, then perhaps cost saving or operational optimization. And to me, and this is one of my last slides, this comes back to this political issue. The communications industry has traditionally had some core standardized platforms, whether it's IMS, whether it's SIP, whether it's radio networks, and everything else is expected to be skews on those, or stem from that centralized vision. But to my view, in my view, that introduces time and friction that we really can't afford anymore. I think we need to move into a world where everything is much more autonomous and there's loose coupling, and we can do integration and standardization later if needed. And I think we need to keep an eye on those eventualities, but I think that we need to also accept an ability to experiment, whether that's on the network side. We're seeing things like Sigfox at the moment as a low power network for IoT, whether that's in enterprise communications, whether it's in the website of the communications industry, voice, everything else. I think we need to not just play with these things in the labs, but actually be prepared to put them out over the fence into the wild, and then iterate. And iterating, it may well be we end up standardizing more, or it may well be we use APIs and platforms to link them together in a slightly more kludgy way, but that's acceptable. So, summing up, to engage with the future, I think there's going to need to be a lot better involvement across different functional groups within vendors, service providers, academia. There is a role for extending out to developer community, hackathons, incubators and the like. And also, there's such a lot of these new technologies, whether it's artificial intelligence or drones or blockchain, that it's not something the telecoms industry is going to be able to do internally. They're going to have to work with the banking guys on distributed ledger technology and blockchain. They're going to have to work with specialists in aerial platforms or video surveillance, or whatever it happens to be in all of these orthogonal trends. And who knows, maybe even the artificial meat as well. So, pragmatism and speed, and I realise I'm not been as fast as perhaps I might have been, but it's 12 o'clock, so I'm almost bang on. I think pragmatism against grandiose and complex visions and architectures, that will make some people wince. I also think that there are so many possible intersection points that not everyone can do all of them. Now, at one level, that means there are defensible niches, but it also means there's more unpredictable risks and threats. I think we need to go to sort of beyond proofs of concept and actually, try to improve our ability to get either the internal finance department or partners to fund proper field trials, whether that's commercial services or pre-commercial or operational. Cost savings are usually easier to justify in some cases, but there's certainly revenue opportunities or things I know, appear in was significantly inexpensive, that it was almost able to be done sort of without a huge amount of direct budget approval. I think there's internal use cases for service providers as well as customer-facing ones. Security, now, this is the tricky one, is that just winging it does imply security risk. So if there's one aspect which I think probably does merit upfront consideration, if not standardization, is the security filter. And I would say the security filter is probably more important than the standardization and corporate acceptability filter. And I think that's probably something that we need to change our mindset on. And I think that also it may well mean that we end up needing more flexible organizations in service providers and vendors to sort of be a bit more open to some of these blue skies, because they definitely are out there, and it's not all doom and gloom in the telecoms industry. Thank you.
In one of your slides, you had a quote that said that telcos and banks will merge. Was that from you or from someone else?
Well, that was from someone else. And there are some overlaps. I think it's like a Venn diagram that is, in some places in some parts of the world. But I don't think AT&T is going to buy Bank of America, or I don't see HSBC and Hong Kong Telecom merging anytime soon. But I know, Orange bought an insurance company in France called Groupama recently. So there's certainly going to be intersections, and clearly, mobile payments is a big deal. But I think the point there was that the futurist who wrote that clearly didn't realise that an awful lot of telecoms business is to do with enterprise, and it's not about consumers doing banking on a smartphone.
Just to pick up on what you're saying, go from out of leave the lab and go into productization. Okay, so Sven, I thought, had an interesting point to that, because we do plenty of proof of concept in the lab, and we're not a business school, so most of the students that are, say, working in my lab are not necessarily going to race out and do the entrepreneurship piece of that. However, I think it's a place where the labs can work with people like the phone companies. And I think that the phone companies and the telcos and everybody else has to begin to see that as an opportunity. When
interns or whatever it happens to be.
Or when we do something called an on-site internship, and periodically we'll just partner with somebody. We sort of fly this under the radar, where the persons actually are paying the student as their intern, but they're working in our lab. So these things are kind of what I said the other day in the IPT we were talking sort of under the radar. We have to find ways to begin working, because we are in a kind of a revolution of the modes of communication and production here right now. We're in a most exciting time, I think, really. And so, partner with a lab. T-Mobile gave us money to build the Bluetooth devices that we're all talking about. It wasn't a big deal where we went through contracts. They just gave us money to build the things, because we didn't have $4,000, which is what it was winding up being. So we got some money. But it wasn't like a big deal thing. And that's, I think, something people have to think about more often.
It's interesting. It may well be that labs like yours are perhaps better at doing that than some of the internal labs at service providers. Because I've been to a number of operator labs and research facilities, and they are full of people coming up with clever demos who are utterly unable to get their own business units to listen to them. I remember on WebRTC going to a European operators lab, and they had a WebRTC platform, and they were trying to sell it to their enterprise business unit, to the voice guys. Nothing. In the end, I think they shipped it out, and they worked with an external partner rather than their own internal business units.
Yeah. So we have the freedom in a lab. We don't have to make a profit this month. Yeah. And so the university labs, if they're willing, I think become a useful place to partner with. I think it's right in line with what you're talking about.
Agreed. Right. Looks like my my throat is pretty much survived intact. So if there's any other questions, my contact details are on there. By all means, get in touch with me. I'm usually in the US sort of once a month or so, and I'm usually complaining about things on Twitter most of the day. Yeah. Well, it depends which time zone, but yeah. Anyway, thank you very much. Cheers.